and I would love to introduce to you our next speaker, whose name is Bill Simpson-Young. He's the Director of Engineering and Technology Development at NICTA and developer of the cesium-based national map, so very into the spatial scene. And with 25 years of R&D experience working with Canon, Unisys, CSIRO and NICTA, he comes at this with an incredible wealth of knowledge. So without any further ado, would you please welcome to the stage Bill Simpson-Young.
Actually, just before anyone thinks, so I didn't actually develop the national map, but I lead the development of it. So I would love to be getting my hands dirty writing code again, but I don't get time to do much of that at the moment. By the way, I think the quality of the talks has been fantastic. I've really enjoyed all the talks so far. I was seriously blown away by the first two talks. And others have been great too. But a couple of the messages that came through from the first two that just really I took a lot away from. One is, so when Larry talked, he was talking a lot. He was showing lots of the big challenges and how data can help us, analyse and understand those big challenges. But the importance of open data. And then Bob Bishop was talking not just about open data, which obviously is important, but also that we need to work together with the open data. And he had the great phrase, interconnected global challenges require interconnected resources, and I fully agree with that. So I think that's a nice point for me to come into, because that's exactly sort of the area that I'm going to be talking about. So I'm going to be talking about spatial data and the web, how far we've come in the last 20 years, what we're doing now, and where we're headed. So first, a little bit of history. So it was over 20 years ago, over 20 years ago that the great Tim Berners-Lee built the fabric of the World Wide Web. And he came up with URLs, HTML, HTTP. And he was making a way, at the beginning it was quite simple, where one bit of information on the internet could point to another bit of information on the internet. So text in pages to other text in pages, text to images and so on. And then slowly it became more interactive with online forms and image maps and so on. And eventually coming to the point is today, where there's this massive amounts of information, a lot of interlinking between it, and a lot of wealth of information, despite, of course, we love the internet, what we do without it. Yes, there's some clickbait out there, but we still get by. Yes, there's too many cat videos, but we still get by. And in particular, actually, I love the one cat video that I'm quite happy is out there. The one of the cat dressed in the shark suit riding the Roomba robot vacuum cleaner chasing a duckling. That to me is sort of hopefully an enduring image of today. Just brings in everything that we care about at the moment. But back at the time that Tim Berners-Lee was inventing the web, it wasn't the first time that someone had tried to do distributed hypertext. People were criticising him at the time. They were saying, look, it's too simple, it's really naive. You've got unidirectional links going from one place to another place. You need bidirectional links because, of course, you're going to get broken links. And experts were saying that I was on a mailing list, a hypertext mailing list at the time, and people were criticising him for this simplicity. But, of course, simplicity worked, and the rest is history. Yes, we still have broken links, but we've got by with the broken links. Now, in those very early days of the web, there were still maps. So maps came out very early. So probably around 93 was probably the first sort of interactive map server. And that was this one here. So this is from Xerox Palo Alto Research Centre by Steve Putz, and this is from 1993. And the idea was you had a geographic database, you had some software running written in the Perl programming language, talking to a geographic information system or to a geographic database, generating images, sending those images down to the browser. You click a point in the map and it goes off, generates another image that's more detailed and shows you that. So really simple. All that was in the browser was an image, but it still allowed a user to zoom into different parts of the web. And then very quickly, web mapping became a bit of a thing, and there was lots of successful online interactive maps. National Atlas of Canada was early. There was the UK site Multimap that was later bought by Microsoft. There was the US Online Atlas and so on. So, and Esri did a lot of work also with web-based interfaces into Esri GIS systems. And then, so this happened. And in 2000, the OGC, the Open Geospatial Consortium, started putting in place standards for saying, look, we need to be able to have different systems talking to each other. We need to standardise the way in which different GIS systems talk to web browsers. And so they came up with the first of many web-based interoperability standards that they've been working on. And so, and they also were very influential in getting involved in, say, the NASA-led Digital Earth to encourage interoperability standards. So it's not just about the data, it's also about how the different systems talk to each other. Now, in an area that's as exciting as the spatial industry, there's lots of really glitzy things. You know, there's wonderful technology in satellites, there's wonderful 3D visualizations, there's wonderful, you know, insightful analytics. But really, there's also the importance of the plumbing. You know, the plumbing is really important. Having the right open data is one thing, but having data services that talk to each other to enable even greater interoperability and more understanding, and doing what Bob said earlier about this importance of the you know, working together on these great challenges. So let's just jump forward a bit. You know, here we are in 2005. In 2004, Google bought Sydney company Where2 Technologies, and in 2005 they released Google Maps based on that. This is the same timing as, you know, the year before. So 2004, Google also bought Keyhole, which in 2005 became Google Earth as well. But Google Earth was not in a browser, so I'm not talking about it. I'm talking about browser technologies. So, you know, this you know, made a big difference to everybody's lives, of course, as things went on. The initial version, actually, of the Where2 Technologies wasn't running in a browser, but the company that built it proposed to Google, hey, we could put this into a browser pretty quickly, you know, buy us out and we'll do it, and they did that. Now, so here we are 20 years later, and you know, what's changed? There's actually a lot has changed in the last, 10 years since Google, 20 years since the web. A lot has changed. We've got far more powerful computers, we've got far better networks, we've got much more graphics processing capability in the computer and in the browser. We've got new standards like WebGL, which has been around for 3 or 4 years now, that means that you can actually have high-speed 2D and 3D graphic rendering inside the browser. You don't need to rely on the Xerox PARC map server, the map viewer approach, where you're generating everything on the server side and sending down images. You can do a lot more in the browser. So that's sort of the context in which we're working. So I'll tell you a bit about what we're doing now on the Australian national map. So a year ago, we at NICTA started working with Department of Communications, Drew Clark and so on, and Geoscience Australia to build a national map for Australia. But at the time we thought, let's not build just another web portal. Let's actually empower, bring more into the browser. And so the browser is talking directly to the data services. Not that there's this big back-end system that is accumulating all this data and rehosting it. What we didn't want to do was rehost the data. We wanted the data to be accessed from the original data custodian. So we started with 10 design goals. I won't go through all of them, but I'll just concentrate on a few of them. So number 3, direct live access from the data custodian. As I said, we didn't want to be yet another site storing data again. If the data is accessed directly from a data custodian, it means they can be responsible for its currency and its quality and its provenance. Number 4, you know, we want to have data from federal, state and local government. Number 7, it need to be vendor neutral at the back end. You know, no vendor lock-in. Of course, different companies, different government agencies are going to use different systems from some of these there are lots of great companies that build lots of wonderful products, but you don't want a system that relies on a particular vendor providing a back end. So it had to be talking open protocols to the back end. And then the last one, platform for innovation. We wanted something that companies and government agencies and the community could build on top of to build more things. So those were the 10 goals, and so we did this, right? So we built some software. Initially, so this is over the past year, we built some software that runs in the browser, so it's all JavaScript. Originally it was called National Map as the software, but we decided that it was a bit confusing because we started wanting to use it for things other than the National Map service. So a month or 2 ago, we renamed it to be Terrier.js for the JavaScript. And it makes use of some other open source software. So, for example, some of you may know the Cesium Geospatial Viewer. That's some software that we co-develop with other organisations around the world, and is also the geospatial viewer that's behind the Queensland, or the QUT globe that the Queensland government and QUT have developed and is in the Cube, which is wonderful. But it doesn't rely on Cesium. It actually works just as well on old machines. It falls back to a 2D mode using a completely different underlying renderer. So it's actually, it's quite a different technology stack on top of Cesium. And the idea is that once you go to a website, the software runs in the browser, and then all of a sudden you're just on your own talking to all these different data services. And it's up to those different data services to give you the data. So I'm just going to show a 3-minute video of the national map. So what you see here is now we're just searching. We're searching in the official gazetteer, so that's actually got a link into the official gazetteer. Sorry about the slowness of the network connection. I did this on my phone this morning, using my phone as a network. So you can see that it's 3D data, it's got terrain data and imagery, all rendered in the browser on the fly. We're now accessing communication data directly from the Department of Communications. So broadband availability, mobile black spots. Those mobile black spots are community contributed points. For any data set, we can go and see more information about it, the licensing conditions and so on. If we want to look at, say, land data, we can look at surface geology. That's coming from a completely different government agency, completely different server. It's coming from Geoscience Australia. If we look at water data, it comes from the Bureau of Meteorology. So if we look at stream data, that's, again, talking to a completely different server that's actually using completely different software at the back end. Some of the software at the back end, some of them are using Esri servers, some are using MapInfo, some are using Google Maps Engine, some are using GeoServer. We don't care, we talk to all of those. Now we're talking to data.gov.au. So that's live connection from my browser into data.gov.au. I'm looking at the Gold Coast. So someone from the Gold Coast Council have uploaded a file into data.gov.au, which has the parks in the Gold Coast. So I'm getting that directly now. So they've just uploaded a file, and I can get whatever was in that file. In this case, where all the parks are and whatever information they have about the parks. They've got all their underground water assets they've uploaded as well. I can see all that information. And it's totally up to the data custodian what that information is. So we have data in here from all the states. We also now have data from ABS, and this is talking directly to the ABS through an API. So the ABS fairly recently, probably just a month ago actually, have released an API. So we can, interactively set filters to show different types of data. At the moment, we're showing age data, different people of different ages in different local government areas. We're just at the first stage of the ABS data, and we're about to have a lot more ABS data available through here. And this is all on the fly. Now, what we're doing now, this is a spreadsheet that's on my desktop. Okay, all this has is a postcode and a value. I drag that into the national map, and it will render that in the national map. And that works even if in this case, this is the city cycles from Brisbane. That has latitude and longitude in there. I drag that in, and it shows me all the city cycle spots. I can, in this case, I can change the part of the spreadsheet that is being used to separate those values and colour them and so on. And I can share the data that I'm looking at by just hitting the share button. That generates a URL I can send to someone, put in a website, and then other people can go to the national map, load all the same data sets and so on. Okay, sorry, I just saw the time. Okay, so, and based on that, so that's the core of the national map. But the beauty is that each of these data services are being made available as data sets. So we're working with the government agencies, Geoscience Australia, Bureau of Meteorology, ABS, and ATO and so on, to make their data easily accessible and using standard data formats. And now we can build a whole lot of themed maps on top of that. So here's one we're doing for the Australian Renewable Energy Agency. It's called the Australian Renewable Energy Mapping Infrastructure. And again, it looks very similar. It's got a lot of the same data sets, but there's also a lot of custom data sets. So for example, electricity generation. We're hooking into different government servers to get all of the power stations in Australia. We're hooking into other servers to get the level of power generation in Australia. We're hooking into other data sets to get transmission lines, to get roads and rail. We've actually spent a lot of time talking to people from the renewable energy industry to say, what sort of data do you want? And then we're connecting all of the different data sets from the different providers all through this open framework that's free to use. So I'll jump through that video. Well, it also has solar intensity from the Bureau of Meteorology, so you can see the level of solar intensity at different parts of Australia at different months and so on. So, and just to show you where we're at now, this week, on Thursday last week, there was a major announcement by Tony Abbott, Malcolm Turnbull and Paul Fletcher of a $385 million program to build and upgrade 500 new mobile base stations. And in the press release that was released at exactly 11 a.m. on Thursday, there was actually a statement saying if you want to see the data or the locations of these base stations, go to the national map, and it had a link to the national map. And we were informed about this. We had the data set ready to go at exactly 11 o'clock, and then 11 o'clock, bang, the data set was there. It was on the national map for everyone to access. And so it was, and got a lot of hits, by the way. But so that's what we're doing, and that, just to show you how easy that is, so rather than the government spending money building a custom website about locations of mobile base stations, they make just one CSV file. So an export from from an Excel spreadsheet, put it on a server, we put a time limit on it, and bang, there you go. You don't need to build a custom website anymore. You just put a file on a server with an embargo time. We've now moved on to doing the same thing, but on a global level. So we've just done some work for IAG, Insurance Australia Group, on building a world map for natural disasters. Now, this is actually the first time, and this was announced by the UN Environment Programme last 2 weeks ago, and it's the first time that there's been a map that has both exposure information about human exposure to disasters, actual historical events, and actual insurance, the insurance situation in each of these countries in different regions and so on. Now, the members of this, the UN's Principles for Sustainable Insurance program are now using this map and going around visiting different governments, showing them the level of spending, the level of exposure, the level of risk in different countries, and trying to encourage programs to address this. So the future is, we're now, the nice thing is that when you're getting all this data available, then you can start doing the useful stuff on top of that. A lot of what I've shown you now is the plumbing. We've been working with these agencies to get these data services out there. And now we can start to do the really interesting stuff, and doing this in an open framework. So one of the areas we're doing is spatial predictive analytics, where we're taking so in this case, we have crime data at a local government area. We don't have it at a more detailed level, but because we've got so much other data, we're using machine learning techniques to do data-driven approaches to understand the patterns that are going on and predict what the data is likely to be at a finer level of detail. And when we've tested this, we're getting about 90% accuracy for things like unemployment, crime, and other things like that. And not just demographic, we can do the same thing with environmental data. We're also, as I mentioned, one of the purposes of the national map is to be a base for other people to build on top of. So there are now a number of companies who are building services on top of that. This is an example of a Sydney-based company which is building, automatically generating 3D models from drones and then putting those 3D models into the national map so that companies can keep track of what's happening on construction sites over time, including being able to load up different data sets from the national map itself related to transport and water and so on, and pipes, but then build their own systems on top of that. And so that's just one example. So just to summarise, what I'd like to say is there's sort of 3 key points I want to just go away with, all that's sort of a common theme. First, interactive web mapping has come a long way over the last 20 years. And one of those trends has been moving from this processing, doing all the processing at the back end and then putting an image in the browser, through to actually making data available at the back end and leaving more processing to the browser. Now, this is really good because it stops a lot of hidden technology sitting behind servers generating simple stuff. You can actually bring the power back into the browser. Secondly, the importance of open data, but not just open data, but open protocols, and preferably simple open protocols. The Open Geospatial Consortium does a fantastic job of defining and adopting these open data formats and protocols, and everyone should be using them. But third, and this is the most important, open data is great, and a lot of people are talking the open data talk. A lot of people, government agencies need to do more on open data services. A lot of government agencies are not particularly good at providing open data as services that people can use at high enough performance for people to use for different purposes. And I think that this is really critical for having this open data infrastructure that everybody here wants, and to unlock the $48 billion that Drew was talking about. We need to do that. And as Bob Bishop said, we need to do that so that we can get this interconnected resources to address these interconnected global challenges. Okay, so governments need to create more data services. So that's it. Thanks. No worries.